Welcome. So in the last couple of videos, we began programming. We did a quick Hello World application. We talked about the different kinds of programming errors that we may encounter. Today, in this video, I'm going to start talking about actual programming concepts. And the first one we're going to be talking about, it's called primitives. So let's get started. So in order to introduce the idea of primitives, let's look at something real quick. So imagine the inside of a car. So you have a dash, right? Like a dashboard that tells you information about your car. So you can have something like a fuel meter that tells you, hey, you need to get more gas. Right? And you have some kind of meter that tells you, hey, you're going at such and such speed. And perhaps you have a few other ones, maybe the temperature of the car and some other stuff. You might also have some kind of panel, and then in this panel, there's some little light bulbs that might show up. Hopefully they don't, but if they do, they might look like something like this, and it said, hey, there's something wrong with your car. You need to check that out. We might also have some form of radio, right? Because we like to be entertained while we drive. And let's say that in this radio, we have some kind of button that allow us to turn it on and off, right? And then let's say that this radio has another knob here, and with this knob, we're able to rotate it from one side to another because we want to change the frequency of the radio. And let's say that we have some panel here, and in this panel, it displays information about what we're listening to. Perhaps the name of the radio station or the name of the song and whatever. Now take a look at what we have here. All of this give us what? They give us information, right? The whole point of having this right here is that it can tell us, hey, what's going on with your car. And the whole point of having this right here is that, hey, okay, we're being entertained as we drive or as we're just parked somewhere, and we want to know about what we're listening to. We want to be able to change it to another radio station and hear something else. All of this stuff is providing to us information. So the concept of primitives is that I like to think of primitives as the building blocks of information. So all kind of information can be saved, or it can be represented in one way or another using the primitives. And we have three types of primitives. The first type of primitives is called numbers. Can you see how many numbers right now are being used to tell us information? Well, for one, we have a little fuel meter that says, hey, you're 50% full, right? The number 50. That is, in a way, information, and it's a number. What else is another number? Well, the speed of the car, right? You're going 60 miles per hour or 100 kilometers per hour. Well, that's a number. We get information from this. What is another number? Well, what about the frequency? Let's say that the frequency is displayed somewhere here. The frequency of the radio that we're listening to, right? The radio station has a particular frequency, 102.9 or whatever. All of those things, they have frequencies. Therefore, there's a lot of information presented to us in the form of numbers. The second type of primitive, I'm going to call it text. Think of all the text that is being used to give us information, like the fuel meter, for example. There usually is an indicator that says, okay, the top part, that means it's full, and then there's maybe a little E at the bottom that says, okay, that means that it's empty. We have other text. For example, we have the name of the radio station. We have the name of the song that we're listening to. All of these things is just using simple words, the letters of the alphabet in conjunction with numbers. So simple text, not mathematical symbols, no numbers. Just it could be using numbers, but numbers in such a way that it is used as a text, not as a number that you do math with. For example, an ID. Sometimes IDs have numbers and letters put together to represent your ID, and those numbers are not used in any mathematical way. They're just more symbols in order for us to, create more IDs and so forth. So we have text. And the last primitive that we have is called a state. Now, what do I mean by a state? Well, in a state is that you either have one option or its opposite. For example, take a look at the power button, right? The radio is either on or it's off. It can be both, right? You can't have, the radio is somewhat on. No, it's either on or it's off. So the state indicates some kind of information that it's either one way or another, one way or its opposite. In this case is on and off in terms of the radio. What's another thing that is a state? The car itself. Is the car on or is the car off, right? So you can use a state to either represent one thing or another, where you have two options. And a lot of the times it's either one thing or its opposite. And this is it. We can represent all the information that we can think of in one way or another using one of these three. Numbers, when we can do math with this kind of information. Text, when we just want to say something or we want to display something and we give meaning to that text. And third, when we want to define the state of something, whether it's one thing or its opposite. To give you an example, let's think of the color red. I can represent this color red by using one of these three primitives. For example, I could say, you know what? If it's red, I'm going to give it the value 1. But if it's green, I'm going to give it the value 2. And if it's yellow, well, I'll give it the value 3, right? So now I can use numbers in order to represent one of these colors. Now, in fact, colors, they're an electromagnetic wave, which has a particular frequency. I could use that frequency as the number that represents the color. But I could use something simpler, like this scheme that I made. I am representing a color by a particular number. Now, I can also do that with text, right? I can say, okay, if you see the letters R-E-D, I'm talking about red. Okay, that's pretty obvious. If I say G-R-E, well, I'm talking about green. And if I say Y-E-L, then I'm talking about yellow. So you use text in order to represent a color, right? And the last thing is a state. Well, I could say, you know what? If it's red, then it's a yes. And if it's not red, then it's a no. So suddenly, I can represent red by using a state. So I say when it's red, it's a check mark. Not red is an X. And it's as simple as that. Using these three primitives, we can represent all sorts of information. Now, of course, I gave you three options, right? Which one do you use to represent some particular information? Well, for a lot of the times, let's look at the colors, right? There's so many different colors. There's so many different shades of red, green, yellow, all the other colors. So to give a name to every one of them, that could be a little tedious. Although there are names, but can you imagine having to remember them? And then also what happens if you're trying to, let's say, have a color that changes color slightly, that goes from red to dark. If you can do some kind of math with it, if you can perhaps increment the color of red, you know, kind of how we increment numbers, 1, 2, 3. Well, we can do something like, okay, there's a little bit of red. Okay, now it's more red. Now it's more red. We slowly increment it. So we can use numbers to represent colors. As a matter of fact, in computers, that is how we represent colors. We use numbers. Now, I'm not going to talk about that right now. We can talk this in a later video, but we use numbers. If we were to use text, then we would just have so many names that we would have to remember. We would need like a table just to be able to memorize them. And if you use a state, well, that's too much, because then you would have to do a little table for each color, where it's like, okay, if it's red, it's a check mark. Oh, but now I'm talking about yellow, so now we have to change. It's a little too much, right? It can be done, but too much. So in this case, we say, okay, numbers for colors. Which primitive you use to represent the information that you want to give out would depend a lot on the type of information that you're given. Lastly, to give you another example, take a look at this YouTube video, right? If you hover your mouse over the YouTube video, you will see a label, like a title, right? Learn programming with C++. That video itself, that title is text. It's giving you information. It's telling you, hey, this is the title. If you go to the description, there's more text. If there are comments, there's more text. So there's a bunch of text just to give you more information. Think of the video itself. You can either pause it or play it, right? That's the state of the video. It's either being played or it's being paused. Now, I hope you don't pause me, but if you have to, go ahead. But again, right, it has a state. You play it or you pause it. And the last thing is, think of all the colors that I'm using, right? I'm using green, red, I'm using yellow, and I'm using all these colors. How are all these colors presented to you? Well, in a way, these are represented internally by numbers. And then, thanks to the screen and all the technology that has been developed by many people, it gets converted to color in the screen so that you can see it. But internally, all these colors, they're just a bunch of numbers that are stored in memory, and they're presented to us in the form of a color. With that being said, we have in mind these three primitives because on the next video, we're going to start writing some code, and we're going to use these primitives in order to use information as part of our programs that we're going to be writing. And this is something that every application is going to have. So this is very crucial. It's not difficult, but it's very crucial to understand the different primitives that we have and how they are applied in the programming concepts. I hope you found this video useful. If you did and you don't mind, leave a like. If you're new, check out the channel, check out the video series. If you like what you see, subscribe. Be safe and peace out.